Hi everybody. So in this video we are going to be starting chapter 8, and this is going to be our introduction then to Calculus BC. While none of these topics that we're going to talk about from this point on are going to show up on the AP exam, this is going to show up then for Calc BC if you happen to either take this class next year as a senior or if you happen to take the class in college. So we're going to be focusing today on trig substitutions for integrals. And we're going to start with something that should hopefully look familiar for you. In this question, we're actually not going to need to do any sort of fancy substitution. It's just going to be straight u-substitution. Remember, I always told you that you should be looking for what is the most complicated part of your integrand. So we either have sine of x, that could be u, or we could have cosine of x be u. Don't let cosine cubed be u, that's not going to work out for us. So between the two, I see if I were to let u equal sine of x, then du is going to be cosine of x dx. But we have a problem. We only have cosine of x, we need a cosine cubed. And we're not allowed to cube du because dx is not cubed. So that was not the proper substitution. I also told you we're not supposed to let u be cosine cubed. The reason for that is because the derivative of this would have been 3 cosine squared x times negative sine of x. And then we would have needed a total of cosine to the fifth, which we don't have, so that's not correct either. Instead, what we're supposed to do is we're just supposed to let u be equal to cosine, because then du will be negative sine. And now we can make our substitution. We do need to introduce a negative to the inside and the outside though. But now we are able to solve this. We're going to have negative integral. We're going to make our substitution here, u cubed du. This will integrate into u to the fourth over 4 plus c. And then we just need to make our substitution back, and that's going to be negative cosine to the fourth of x all over 4 plus c. So not too bad for this first one. But for Calc BC, we're going to have to do some more complicated trig substitutions, and that's going to be here. So what we want to do, we need to remember a couple formulas that we have learned in the past. First one, the Pythagorean identity, sine squared plus cosine squared equals 1. And a hint for you is that you often will use that whenever you happen to see either sine or cosine has an odd degree. And we're going to do a couple examples that will demonstrate how to solve those. Then the next part, these two formulas, which we've used to learn how to integrate sine squared and cosine squared, we're going to often use those then when sine and cosine, both of them, when both happen to have an even degree. So some of our trig integrals will require these identities. And as a reminder, when you are doing u-substitution, you only want u to be sine or u to be cosine. You don't want to be adding exponents. You don't want to be adding anything to make it more complicated. Just that is going to be necessary in order to solve these. All right, here is our first example then. We're going to integrate sine cubed times cosine squared d theta. So my hint to start this off is that we're going to take sine cubed and we're going to break it into sine squared times sine. So that's going to look like this. And then we still have cosine squared of theta, d theta. Then the next part that we're going to do is we are going to take either cosine squared or sine squared, and we're going to use the Pythagorean identity. Because remember, we're going to use that because we started with an integrand where either sine or cosine had an odd degree. In this question, I am going to choose sine, and here is why. We're going to have to do a u-substitution. Our du is going to have to be either sine or cosine. And the problem with changing cosine squared, I'm going to demonstrate here. if we change that into this, the problem we run into, we have nothing but sine. There's no cosine anywhere in the integrand. So u-substitution would then be impossible. That's how I know that we're not going to do cosine squared. Instead, we are going to change sine squared, and that's going to turn into 1 minus cosine squared. I'm going to rewrite this. I'm going to move cosine squared to the middle, and then sine of theta, I'm going to move to the end. And now I'm going to distribute cosine squared into the parentheses. And now that we are here, this is where we are going to do our u substitution. If we let u be sine, du would have to be cosine, but the problem is we can't have du squared, we can't have du to the fourth. So instead it should be u equals cosine. Remember I told you just keep it to be a degree of 1. Du is going to be negative sine. Therefore we need negatives inside and outside. And then we can make our substitution. We will now get negative integral, and then it is going to be, so this negative is going to go with sine over there, and then inside the parentheses we're going to get u squared minus u to the fourth du. Then we can integrate. We'll get u cubed over 3 minus u to the fifth over 5 plus c. And our last thing is that we need to substitute back in the cosine that we took out. So our answer is going to be negative cosine cubed of theta over 3 minus cosine to the fifth theta over 5, and then plus c. There you go. There's the answer. This is a similar question then. So go ahead, try this on your own, pause the video. When you are done, then start it up and I will show you how to do it. Okay, for this question then, it is very similar to the last one. However, even though both of them have odd degrees, that's okay. You just need to pick one and split it up into sine squared and sine. Or you could do cosine squared and cosine. Since I said sine squared and sine first, I'm just going to go ahead and do that. So we got sine squared times sine times cosine cubed dx. This time I will once again take sine squared and I'm going to turn it into 1 minus cosine squared. I'm going to move cosine cubed to be in the middle. I'm going to move sine of x to be at the end. So then I can distribute, and now we are going to have cosine cubed minus cosine to the fifth. And then it'll be sine of x dx. We can do a u substitution. Again, it looks just like our last one. U is going to be cosine, du is going to be negative sine. Include dx. We need a negative inside and outside our integral. So now we're going to have negative, and then it will be u cubed minus u to the fifth du. We will integrate, and we get negative u to the fourth over 4 minus u to the sixth over 6 plus c. And then when we substitute back in, we are going to get cosine to the fourth of x over 4 minus cosine to the sixth of x over 6 plus c. And that is the answer. Okay, so now we're going to move on to a different one. In this question, what we have is sine squared and cosine squared. Now, back from earlier, I told you, still in the box there, when both sine and cosine have an even degree, you are going to want to substitute this fraction, 1 minus cosine of 2x over 2, and 1 plus cosine 2x over 2. So let's start by rewriting the integral like that. 1 minus cosine of 2x over 2 and 1 plus cosine of 2x over 2. Now these fractions are conjugates, so we should go ahead and multiply them together. We're going to get 1 minus cosine squared of 2x all over 4. Then I'm thinking we've got a 4 there, so we can take that out and turn this into 1/4. And then we can also break this into two fractions. So now what we're going to have is 1/4. The integral of, that will be just 1 dx, minus the integral of cosine squared of 2x. So we're able to solve that first integral. That's going to be really easy. But then the second integral is going to be a little trickier. We're going to have to make another substitution, just like what we did up there at the beginning for cosine squared. Now we do have to be a little careful. This time we happen to have a 2x, so it's important for us to know this. Cosine squared of ax is going to be the same thing as 1 plus cosine of 2ax over 2. So we just have to be aware of that then when we make our substitution. So now down here it's going to be still 1/4. I'm going to hold off on integrating that first integral for now. We're going to substitute. This becomes 1 plus cosine of, since it's an a value of 2, it is going to be 4x all over 2. All right. So next thing then, let's start integrating. Well, let's see, the second integral, let's break that up into two parts. So then we've got 1/2 dx, and then the last part. Now we have to be careful because it's minus, and then we've got to include that for both of those. So it's going to be, I'm going to put parentheses there, and we are going to have plus the integral of, I'm going to factor out that 1/2 as well. Or no, I'll keep it in there. Okay, now let's start integrating. So the first part, as I said before, integral of dx will just be x. Now the integral for the 1/2 dx is going to become x over 2. And then we are going to add, and this part here, let's be very careful when we're integrating this. The antiderivative of cosine is going to be sine. And remember, we have to also divide by the derivative of the inside. So I put 2 in the denominator, but that wasn't correct because it should have been, we also divide by 4, so the denominator is supposed to become 8. And then now we got plus c. And the final thing, let's simplify. So I've got that 1/4 in front that can combine with everything. X minus x over 2 is going to leave us with x over 2 times the 1/4. We're going to eventually get x over 8. And then for this second part, let's distribute that minus sign in, and we're going to get sine of 4x over 8 plus c. And then the last part is, I'm just going to distribute everything in. You don't need to, but I'm choosing to. And we're going to get sine of 4x over 2, I'm sorry, my mistake, over 32 plus c. And that's it. So here is the assignment. On your assignment sheet, you actually have questions from 2 pages. I have decided to move the second page of questions then to tomorrow's video. It's also going to be different content. I think this is going to be easier. Once again, as usual, go to Schoology to see what's required and what is optional. Thanks for listening, everybody.